we're going to get started by talking about the DOM and accessibility. And so what we're going to do is break down the topic of understanding how our web pages interact with assistive technology in a bunch of different ways. When we talk about accessibility, the first thing to know is you'll often see this abbreviated as A11Y. It is sort of just programmer speak, long words that get sort of abbreviated. You might see I18N as internationalization or L10N as localization. But if you see A11Y, that means accessibility. And the goal here is to think about ensuring that our apps work for everyone. And when we say everyone, we mean everyone in just about every situation. Typically, we will talk about disabilities, but it's important to remember that accessibility is not just about, things that would be clinically classified as a disability. If you are in bright sunlight and your phone screen is a little bit dim, or as you might know from being a student, like seeing things on projectors which have poorly calibrated screens and not good contrast, all of these things affect our ability to perceive and understand content. And so that's what we're going to be focusing on. And one of the things is, to believe it or not, the code quality at a markup level, at a CSS level, these things affect the accessibility of our app, even when it's not obvious. And so one of the goals here is, obviously this course is about writing beautiful code, doing it in a intelligent and disciplined way, but this also has positive impacts for the accessibility of our applications. And finally, what we're going to talk about is the DOM has robust APIs for interacting with what we call assistive technologies, or sometimes abbreviated as AT. So this includes things like screen readers, other types of braille displays, other types of input devices. So there are input devices, right? Keyboards, mice, touch screens, trackpads, but you might have different kinds of switches, perhaps if you work with, or if you're in a wheelchair, where you want to interact with a tablet or something like that. So there's all sorts of input devices that go beyond perhaps just the keyboard and trackpad that you're used to on a laptop. And so the APIs allow us to interact with those devices in a more declarative way. And it turns out there's a lot here, but some of it is quite easy, and some of it are interesting and fun design challenges. So why does accessibility matter? Well, it depends on the reason for what motivates you. I think a lot of us would say, right, accessible apps are just the right thing to do. If a user has a disability that's preventing them from using the app, you should just build it for them, and you should fix it so that they have access to whatever you're trying to do. The general other reason is that if you're a business person, you might argue that it just makes business sense. The WHO estimates 2.2 billion people in the world have some form of visual impairment. A lot of those could be perhaps corrected or augmented by glasses, but certainly not all of them. There's an estimated 1 in 7 people in the world that have some sort of registered condition that could be classified as a disability. But also, at least today, everybody gets old. And as you get old, your ability to perceive, read, hear things changes over time. But finally, we could say that designing for accessible interfaces benefits everyone. I'll try and show some examples of that. But thinking about the ability to do things like light and dark mode is not just a convenient feature. It's also something that promotes the accessibility of an application, because it turns out, right, that in dark light, you don't necessarily want a bright screen. A lot of you as programmers probably enjoy dark modes. This is one of those things that comes out of an accessibility feature that turns out to benefit everyone. And if none of these things motivate you, well, it turns out that in many places, not just in the United States, but around the world, accessible applications are a legal requirement, and no one wants to be sued. So whatever your motivation might be, there's a bunch of different reasons for why building accessible applications might matter. So what does it mean to build something in an accessible manner? If you don't have experience, it might be hard to do this, but the first thing to think about is just what are the considerations and the different modalities in which someone might interact with your app. You have a desktop computer, you have a phone, you have it in your workplace, but you also have it out in the world. What if you have a new device, an old device? What if your vision isn't so good, or you rely on hearing some content and your hearing is impaired for some reason? So really what we're trying to think about is, yes, there's a default mode that we might be used to for interacting with our app, but just because we can see it on our screen doesn't necessarily mean that everyone else can. When we think about this, one of the ways to think about disabilities is not just the clinical sense, but thinking of them as a mismatch between a user's needs and their environment. And this is particularly helpful to consider because a lot of disabilities might present themselves only in certain situations. So I'm going to use the example of walking into the sunlight and not being able to read your phone screen because the website has too low of a contrast, perhaps. Or maybe you've recently gone to a concert and so you can't hear so well, and so you rely on things like closed captions for a little bit just to watch a video. Or maybe you don't speak a language, and so closed captions provide a translation. And those can all be forms of accessibility in our application. Broadly speaking, the W3C, the World Wide Web Consortium that provides a lot of these standards, they break down the considerations into a few different parameters. But if we're thinking about the types of interactions that we might have, we might think about auditory conditions, so content that requires hearing, cognitive and neurological conditions. So is the writing, the iconography, the information hierarchy in our application understandable? Physical interactions, so motor movements, device input, whether or not typing, drawing, things like that are required. Speech, does your application require someone to speak content into it? That's probably not the case for many of the apps in this class, but you might be doing something that, is an app that helps people record some devices or translate some content, so that could be a consideration. Finally, for most applications, the visual considerations. Not everyone has consistent eyesight. Obviously, there are people with complete blindness that can't see anything at all, but there's many more subtle shades from just correctable vision with glasses to color blindness and just about everything in between. So the spectrum here of user needs is quite broad. And finally, with all of these, the W3C gives you an intro to the types of things that you might think about. But really what we have here is sort of the intersection of things like disability studies and technology. So what becomes important when we're talking about designing accessible applications is how we navigate pages. Most of us, by default, navigate pages by scrolling through them, perhaps just moving a trackpad, clicking on links and buttons. But it turns out that for a large number of users, there are different ways of interacting with pages. And this one I think is fun, is starting to think about interacting and navigating pages with the keyboard. For those of you who, find yourself enamored with keyboard shortcuts and sort of the speed of some of those things, the pull here is, it can be more efficient without, even necessarily needing to rely on it, but it could just be more convenient. So if you can't use a mouse for some reason, if you imagine someone with Parkinson's where you have really shaky hand movements at sometimes, that could make clicking on something difficult with a mouse, so you might use a keyboard. Others, we'll talk about screen readers in a moment, but also rely on keyboard interaction to navigate. And so what happens here is most of the time, you're using the keyboard as a means of navigating content on a page. So the tab key, the space key, and the return key typically provide interactions which let you navigate between user interface elements. And we'll demo this. But you can imagine, right, that if you start at the top of a page, you press tab, and tab lets you cycle through the various links that you can interact with. You can hit enter to navigate to that link, or you can hit enter to trigger a button action. And what's important here is that the browser relies on properly built HTML elements to understand whether or not something is a link or a button such that we can interact and click on it. Of course, there's lots of different things that we might consider, but one of the things that navigating through with the keyboard implicitly reveals is that when we tab to an element, it becomes focused. And it's important that we reveal that focus to the user in some visual way, such that as you hit tab, you can see what element you're looking at. And it turns out that the nice thing is most of the time you get this by default. If you're using a framework like Bootstrap, if you're using standard HTML elements, you'll be set up in a good place. But when you start building custom pages, custom designs, you have to consider these in a little bit more detail. And of course, HTML provides all sorts of mechanisms for customizing that. Finally, the second type of interaction that we'll look at today is navigating pages with a screen reader. And screen readers are devices that take the text markup and generate spoken word audio descriptions from that text content. So it's very natural, right, that you can imagine that if there's text inside a paragraph tag, a screen reader, of course, knows how to read that. That's already native text. But really the goal of a screen reader is not just to expose the text content, but to take a link and expose it to a user such that they know that it's a link. Or when you use a heading with heading level 1, 2, or 3, or so on, is to let the user know that this content is a heading, which implies that it has perhaps more important meaning or some information structure to the page. Screen readers rely on the semantic properties of HTML elements, such as using a link as the mechanism for navigating a user, or labeling something as a button such that the screen reader knows that this is a thing that could conceivably be clicked on in some form. The goal of a screen reader is to also look for things that are not necessarily visual in nature, like images, but to then find text forms of those images, or if you use iconography, such as things like a speech bubble icon, perhaps. So screen readers look for special HTML attributes like the alt tag on an image or the label property, which works on just about any HTML element, as generating a text description. So one of the things that, as you start building apps, is you'll have to specifically consider what is the textual representation of a particular element. And we'll actually take a look at some of those in a moment.